Welcome to qnawire.
In this question, we have a collision between two billiard balls. So before the collision, okay, the cue ball is approaching the second ball that is at rest, and with an initial speed v1i, okay, and then after the collision, both of them have the same mass, okay. So after the collision, the cue ball went up at an angle of 22 degrees with a speed of 3.5 meters per second, and then the ball that's at rest went down, okay, with an angle theta from the horizontal with a speed of 2 meters per second, okay. So we want to find the angle theta and the initial speed of the cue ball, and to check that whether the kinetic energy is conserved. Okay, so this is a conservation of momentum problem. So we'll be using the conservation law to write down two equations. Okay, and this is our coordinate system. So going right is positive, going down is going up is positive. Yeah. So along the x direction, here we have m v1i is equal to m times 3.5 cosine 22 degrees plus m times 2 cosine theta. Okay. Then for the y direction, okay, if you look at the diagram, okay, we have 0 is equal to m times 3.5 sine 22 degrees minus m times 2 sine theta. Okay, so we have two equations, 1 and 2. We can obtain theta from equation 2. Sine theta is equal to 3.5 divided by 2 sine 22 degrees. Okay, so this is 0.656, and theta is equal to 41.0 degrees. Okay, so this is the answer for part A. Okay, next in part B. Okay, we want to find the initial speed of the cue ball. So from equation 1, okay, so we have v1i is equal to 3.5 cosine 22 degrees plus 2 cosine 41 degrees. And you calculate this, you get 4.76 meters per second. Okay, then in part C, you want to check whether the kinetic energy of the system, of the two ball system, is conserved. So we will find the Ke before the collision. Okay, so this is equal to half m v1i squared. So this is half times 4.76 square m, and this is 11.3 times the mass. Okay, and then the Ke after is equal to half m. Okay, the first ball is traveling at a speed of 3.5 meters per second, and then the second ball is traveling at 2 meters per second. When you do the calculation, you get 8.13 m. So you can see that Ke after is less than Ke before. Okay, so Okay, the kinetic energy is not conserved. Okay. Okay, and that's all for this question.